Hey, g'day, it's Prezzo. Guess what? Big box just arrived in the mail. Alright, so what's in the box? Well, I don't know because I haven't opened it yet. And this was sent to me by a gentleman named Roger Taylor. Now, Roger got in touch with me via YouTube. He'd been watching some of my videos. And he asked me if I was interested in making up this kit that's in this box. Now, he didn't just ask me, he asked a lot of other YouTube creators. And apparently I was the only person who put my hand up and said that I would do it, which is sort of the story of my life, really. And I just looked at how much it cost him to post it here. It's like nearly $90 US to get this to me here. So thanks very much, Roger. I didn't realise it was going to cost you that much. But the story to this is that Roger had a professor at the, I'm just reading this off his email, Professor of Industrial Technology at Long Beach State College in California. And his name is George Genevro. Now, George had a bit of a sideline in making kits out of aluminium and cast iron components and raw stock, and these kits would be put together, and the idea was that they would be given to machining students to complete a project. Now, Roger said that out of 15 of these kits that he'd given to various students, due to various errors and time constraints, not one of them ever ran. And he would love to see one of these internal combustion engines running. Now, I've done a lot of engines before. I've done steam engines, both as stationary and locomotives. I built a jet engine, built electric motors, but never an internal combustion engine. So that's why I was keen to have a go. So what we're going to do now is open the box and look at all the bits, and then we can make a start on the machining, or at least I can plan how I'm going to do this. So, the other thing was that when Roger said I could make it, he said you can keep it, and what I suggested was that I would rather actually send it back to him. And what he's hoping is that we can put this into the Joe Martin Craftsmanship Museum in the name of George Genevro. So that's the plan. If I get this thing running, I'll send it back to Roger. He's going to put it in this museum to honour his professor, and hopefully we can make all that come good. Okay, so let's see what's in here. Okay, there's a lovely letter in here, and it's signed by Roger, old retired metal shop teacher, which is also descriptive of me. All right, magazine. I've actually got a number of these magazines upstairs. I used to buy this fairly regularly. I'm not sure, maybe there's some reference to this engine in this magazine. We'll have to have a closer look. Now this is the thing I was hoping I was going to get. So it's called the Titan 60, so 0.6 of a cubic inch, I'm guessing. Classic nitro engine for model aircraft. So here's our cross section. Now it looks simple, doesn't it? But trust me, it's not going to be simple. And alright, so we've got some raw stock here. This is the main casting for the body of the engine. And that's beautifully cast. If that's a sand casting, I'm really impressed. It'd have to be, wouldn't it? So probably done in like a cool set. But yeah, very nice casting. Really sound, no porosity. That'll be a joy to machine. So I've got some other, it's actually a tap. I think there's a glow plug with this as well. So this is probably the tap for the cylinder head to suit the glow plug. Alrighty. You know what? I'm going to get all this unwrapped and we'll look at the parts. Okay, well here's what was in the box. Now there are 3 castings. So this is the main body of the engine. This looks like the cylinder head. This looks like the back crankcase seal, and also a mounting for the engine itself. Now there's various other bits of bar stock here. There's a piece of what looks like cast iron. We've got some brass, some aluminium. There's a piece of thick wall tubing, some high quality machining steel. There's some more aluminium bar stock, and there's some fasteners. So these are all socket head screws. Now there's also a 1/4 by 32 tap, which I'm guessing is the correct tap for the glow plug. Now there is no glow plug in there. I thought Roger had indicated there was one, but I might have misread that. But I've got glow plugs, so that's not a problem. So that's all the stock. Oh, and this little gadget here is a tool that Roger said they made with students. It's just a little bevel gauge. So that was just a little metalworking project they assigned to their students. Now, there's also a really nice letter here. I've had a quick read through this. And it's just got some backstory about where the project came from. And bonus, he's actually met Mr. Pete. So this is Roger on the left, this is Tubal Kane and Mr. Pete, and apparently they met at the Barzy Bash. So there you go, three shop teachers in a way involved in this project. Now the other thing is that this came with a really detailed set of instructions, and this was something I was most concerned about, but these instructions are very specific to this project, so I'm going to read through all of this and then we'll make a start on the first part, which is the crankshaft. Okay, the first part in these notes that we need to make for the Titan engine is the crankshaft. Now we're supplied with this piece of raw stock here. In the notes it specifies 1018 steel. That could be what that is, I'm not quite sure. But it's 1 7/16 diameter and it's got a finish at 3 3/4 inches long. It's a bit over length at the moment at roughly 4 1/4. And in the notes it says that what we need to do is face and center both ends, and I'm going to machine this back to almost its correct length before we do any more features on that. And it's basically a between centers turning operation. Now the notes say to machine the crank pin end first and then to flip it. In order to do that you've got to be able to drive it from that end with the crank pin. So it suggests making up this little tool here, which is like a drive center. I've already done that. So there's our drive center there. This is set up in the forge yaw and it's dialed in correctly. And this pocket is what's going to drive the actual crank pin that we've already machined. This little 60-degree point will need to be machined just before we fit the part to ensure concentricity. And so that's ready to go. The other thing I've done here is I've actually drawn all of these parts again in my 3D CAD program. I use Autodesk Inventor and I've done dual dimensions. Now, I normally work in metric and I can relate better to metric dimensions. So when I see 6.35, I know what size that is. 1/4 inch, yeah, I'm pretty on board with that, I know that. But then you get these other, dimensions that to me, they don't immediately make sense. So that's why I've done the dual dimensions. I've also noticed that there are some slight discrepancies in the drawings. So these drawings here, I think that these have probably been done with a 2D CAD program like AutoCAD, and in that situation the draftsman is the person that decides where all of the lines go. And for example, in this drawing here, the chamfer on the crank web is in a different position to where it shows up here in this drawing here, and the width of the chamfer over in this view is different to what we see here. So doing the drawings again just allows me to verify that what I end up with on my machine part tallies with the drawings. If there's slight errors in these drawings, it can be misleading. Well, we've faced and centered on both ends now, and that winds up at just under 3 3/4. so that's within the tolerance on the drawing. And you would have seen me drill this end a lot deeper, and that's so that when we do all this work at the crank pin end later on, we've still got the center where we'll be drilling our port through the center of the journal. So if we didn't do that, we'd lose that center after we've done all the machining of the crank pin. So that's the next step. Here's the setup so far. What I need to do is to offset from the very center of that stock to 11.11 millimeters. That will be the center of the crank pin. Now I've swept this indicator around there, and I reckon I got that pretty close, and I've zeroed the DRO. I only just bought this indicator holder, and it may as well be made of chewing gum, really. It's so flexible. Just any movement at all and I can move that indicator, but I'm getting a consistent result all the way around. Alright, so let's do the offset now, and we're going to drill, just center drill, and then that's going to be what we need to pick up on next. I've just brought the knee up and I can drop that center drill into that existing center, so I'm pretty confident I got that set up right. So we're now going to offset by 11.11. So there's our position there. It's 11.11, 7/16 of an inch. So I'll go ahead and center drill that. Alright, cool, back to the lathe. Alright, this is the setup that I'm using to do the crankshaft, or at least the first operation, and I'm using my biggest 4-jaw chuck, and for a big diameter chuck this has got really puny jaws on it, and it means that I can only grip the stock by about 25 millimeters or an inch at this end, and I've got a lot of stick out, and I know these jaws aren't particularly accurate. However, I've got this running to within probably half a thou, and the actual centering of that crank pin is not quite so critical. What is critical is that we've got the stock aligned with the axis of the lathe. So if I run the indicator along that side there, it's not perfect, it's close, it's actually better this way. So it's close enough for what I'm doing now. So what I've decided to do is I'm going to rough this end out. I'll leave everything a bit oversized, then I can flip it and machine all of the other end of the crankshaft. Now when that's all reduced in diameter, I can fit it through the bore of the chuck, and we can do a better job of aligning this end. Just establishing a shoulder there. I'm just going to rough it all out down to that shoulder there, and then we'll do some more precise measurements. That's where I run into trouble with this diamond tool holder. I just simply can't go any closer because it fouls on the tailstock center, and we're not quite cutting a full diameter there yet. Getting close. And this is the drilled hole that we put in originally, and this is going to allow me to pick up that center when we support the whole crankshaft between centers, and also continue that drill hole and enlarge it for the transfer port between the front of the crankshaft and the crankcase. So that's absolutely essential that we have that. So I'm going to swap out to a different tool now and keep going. Alright, I've got a full diameter there now, so I'm just going to check my size. Okay, about 1mm oversize on diameter for now, but what I'm going to do is to hog out some material around the crank pin. So the crank pin has to be longer, but we have to leave some stock here, which is going to be the sort of counterweight. So that's going to be fun, because I might have to say goodbye to my tailstock to do this, which I don't really want to do. But at this stage we're just roughing things out. It's getting late in the afternoon, I've got to pack up, but I've just had a quick go at machining out that pocket around the crank pin, and it's a very tenuous sort of setup. I've got no tailstock support. I know these jaws aren't good in this 4-jaw chuck. The last thing I want to do is have the tool dig in and cock this piece of material sideways in the chuck. So I'm going to have a break now, think about it. There's also the issue of how do we measure the diameter of this pocket here, or the radius that we've got to get. And it sort of means you've got to work off the diameter of the finished crank pin and then set your DRO and then move out from there. But I haven't finished the diameter of the crank pin yet, so I think everything at this stage is just going to be roughed out, and we're going to flip it and do the other end. I had a chance to sleep on this overnight and work out how I was going to do this recess in here, and I've ground up this high-speed steel tool, and I've got all my clearances and so on, and I just tried it out. It actually cuts quite well, but I'm going to have to take very light cuts, and I can get in right to the outside diameter of that crank pin. So I can get right up to the crank pin with some clearance in behind the tool here. This flank of the tool here is close enough to 45 degrees, but I'm just going to rough this out at this end, and then we're going to flip it. So I'm going to do this off camera, so I've really got to concentrate on what I'm doing here. I'm going to get my head in the way so I can see what I'm doing. So we'll come back when I've got this recess almost the right depth. I've got a mark right out to this shoulder here, which is very close to my finished size. So yeah, just roughing out, and we'll come back. Well, there's all of the preliminary machining done at this end of the crankshaft. Everything's oversized at this stage. This is the center we need to pick up on next at the headstock end, and we'll be supporting at the tailstock end here. And then we're going to do all of the finish machining on this section of the crankshaft. So I won't show you all of it, we'll just sort of stop at various points as I do each feature. And then we can turn it back again and finish this end off, but I can grip it more securely, so I'm not worried so much about anything slipping or grabbing when I do this for the second time. Just remachine that center there so that when we set this up we can be sure that that's absolutely concentric. And that's how we're going to drive it, with the crank pin in that pocket. Well, there's first the roughing out steps, and what I've done is I've reconfigured this drawing, and I've got all of my dimensions now from what will be the tailstock end of the material. So each feature is now dimensioned from that one end, which is a bit easy to follow when you're doing this sort of thing. And yeah, I should be doing something about my chip breaking strategy, but yeah, that's alright. Got plenty of time. I'm just about to do the last cut on this crankshaft journal here, and it's given me all sorts of grief. I realised that my tailstock was not aligned with my headstock. Luckily I caught it in time, and I've just spent the last 3 hours trying to get the alignment correct between the tailstock and the headstock. And of course that shows up on a job like this where you're turning between centres. If it's not right, you're going to have a taper in the shaft, and that's what I had, and it was a long way out. Like I'm talking 0.2 of a millimeter, and the reason for that was that I recently leveled the bed of the lathe and I aligned the headstock, but I didn't align the tailstock, and that's what's thrown it out. But I've got about 0.6 of a millimeter to take off here, and measuring this at both ends, I got 14.38 millimeters, 14.37, so I'm about 100th out over the entire length of that shaft. The actual journal length is less than that. That's as close as I can get it. Every time I make the adjustment and then tighten up the nuts under the tailstock, it goes out. So I've just left them snugged up but not tight, and I'll finish this job and I'll fix it later on. But we've got about 0.6 to come off now, and then I'll leave it just slightly oversized. We can always sort of lap that later on to bring it dead on size. I've just done an area on the end here, and I got 14.26, which is right in the middle of our tolerance range. The dimensions on the drawing were given in thou, and given that I'm working in hundredths of a millimeter, that's a much finer tolerance, so I'm happy that I got that in the middle of that tolerance range, and there'll be some material there left over that we can lap later on. Alright, that's the really worrying part done. The rest of the features on this now are way less critical. So you've got a threaded section which will hold the prop nut, and another slightly larger diameter that would be the prop driver. So I'll go ahead and get those done, and then we're going to single point thread the end of the shaft, and yeah, we'll tidy up this surface here. This is just slightly undersized, but that was the original diameter of the bar stock, so I'm just going to clean that up. That's really not critical, that dimension there. Whew, alright, I was really worried about that bit. Just doing these last two cuts with two balance cuts. So I've got 1.02 to come off, which corresponds with my DRO. So that's where the prop driver will go, just there, and now we're going to reduce this section down to 5/16. So at 2.18 oversized, that's two balance cuts, 1.07 each, no 1.09 each. That should bring us spot on to size. Uh, 1.08, I calculated 1.09, close enough. This end of the crankshaft's got to be threaded 5/16 UNF, and I'm going to try and single point it, and I've got a die which I can use to chase that thread. But I want to have a go at doing the single point, and I'm going to try retracting the tool when I get to this mark here. Apparently you're not a real man until you've done this. So I'm going to, instead of cutting a thread relief, I'm going to try and retract the tool right on that mark there. But for some reason my brain just freezes when I get near the mark, and I can't seem to coordinate my hands, but we'll give it a go. Alright, looks legit. Like a boss. I'm pretty sure that's good, so we'll follow up with the die. This is the setup for chasing the thread, so I put this in the 4-jaw, protecting that surface with some copper, and got this end dialed in, and now we can cut the thread or chase the thread, and then we're going to flip it and do the other end. This is the setup for finishing off the crank pin, so it's just a little bit oversized at this stage. So I just got the square collet block in the 4-jaw chuck and I've dialed in the crank pin. So I'll do some cleaning up there. We also need to drill a hole right through the crank pin from this end right through to the back of the crank disc. I'm not quite sure why. It doesn't really serve any purpose apart from maybe lightening that part of the rotating mass. And we're going to drill the gas passage right through the centre of the crankshaft itself. So I'll just give you a brief look at all of that, nothing terribly exciting there, and I'll catch up when we're done. That's the crank pin finished. I'll give that a bit of a polish up before I take it out, and then we just got to bore out the gas passage. Well, that is the gas passage. It's going to bring the fuel air mixture from the venturi of the crankcase through to the back of the crankcase where it's distributed up to the cylinder. And in the notes it says this should be reamed, but I don't have the appropriate size reamer, so I'm going to have a go at boring that. Just, I don't know why it needs to be reamed, but we'll bring it out with the correct diameter anyway. That was a letter X drill that I used for that. And that should bring us to our finished size, and then we're pretty much done. Well, that's as far as we're going to get in today's video now. This is not quite finished. There's a couple of operations still to be done. One is to machine these flats down either side of the crank web. So they will come from a point either side of the crank pin down to a quadrant point at the edge of the crank disc. and we still need to drill a hole through which will form the induction port. So the way this engine works is as that port passes the venturi of the engine, it sucks an air-fuel mixture through that port, down through this bored hole that we've just made, and into the crankcase. And at nearly 10 cc's, this is a relatively large model aircraft engine. And just to give it some scale, this is a Cox .049 glow plug engine. Anybody that flew model aircraft as a kid, if you had probably your first aircraft was one of those Cox control line ready-made aircraft, and this was the engine that was fitted to it. So you get some idea of the size difference between this and this. And I'm quite happy with the way this has turned out. I think it was one of the more critical parts for the success of this engine, and it went way better than I was expecting. So in the next episode we're going to be making the crankcase. So this is the casting we'll be dealing with. It's a mixture of lathe and milling machine work. And I've read through the notes, and this part's relatively straightforward compared to this. I know it looks complex, but the machining operations are fairly straightforward. So that's where we're headed in the next episode, so please join me for that. Thanks for being with me today. Appreciate you hanging out, and in the next episode, getting busy with that. So join me. It's going to be fun. Cheers. Press on.